So very good morning my dear students. Today we are going to head to the next topic, that is to integrate sum types. So from this video we will be going to the other level of integration, that is called the harder level of integration, I mean to say. So I request you to please understand the things very seriously and thoroughly from this video, because till now we have seen some standard integrals which are very easier to solve, but from now we will be seeing some new types, how to integrate the new types of functions. Okay, so today we will only study about how to integrate if you have such questions like this type or this type. So if we go inside each and every type, you see this is a form of quadratic equation. So how to solve integration of dx upon ax square plus bx plus c? Say for example, if you have such type of question, what to do? Say for example, if you have such type of question, then what to do? This is plus. Or if you have such type of question or such type of question, then what to do? So today we will be going to focus on this four forms. I'll take just one example and I'll explain you the full process of solving each and every method. So just fit those process in your mind and apply in any of the formula, you will always get the right answer. So it is all about the algorithm. It is all about the process which you have to remember how to integrate the particular thing. Okay, so let's get started with it. So here is the first question. Integration of dx upon x square minus 4x plus 8. Is it of form integration of dx upon ax square plus bx plus c? Right? So you have this question. Now how to solve this question? But before solving this question, I just want to make you one thing very clear. We are going to use the completing the square method in solving the quadratic equation. In the 11th class, I have explained you what is completing the square method, and it is the method which is used to prove the formula method, that is x is equal to minus b under root minus b plus minus under root b square minus 4ac upon 2a. How this formula has came? By the help of completing the square method only. So I'm again recalling you, just have a look here. This is x square minus 4x plus 8. So this completing the square method also contains some certain steps which that also you have to remember. Okay, so what does the completing the square method states? That your x square should be unity, means there should be no coefficient with x square. So we already have no coefficient with us, that is 1. Unity is there, so we don't have to divide this equation by any of the number. If it could be 2x square would be there, so we have to just divide this, we have to take 2 common, okay, just to make this x square unity. I mean to say you need to take 2 common in the denominator, and this will be divide 2 and this will be divide 2. So we don't have such case, so no worries. I'll explain you for that case also, so don't worry. Okay, so you have x square minus 4x plus 8. Now if I ask you what is the coefficient of x, so what is the coefficient of x? 4. Don't take minus 4, just take 4, the positive value. Divided by 2, you will get 2. Now square it. So the square of that particular number you have to add here and you have to subtract here. Now you would be asking me, sir, why are you doing such type of thing here? So let me give you the proof for that also. If I ask you what is a plus b the whole square, you will tell me a square plus 2ab plus b square. Now, if I ask you, if you have a square plus 2ab plus dash, Can you tell me what will be this term? So what we do, we divide this 2ab by a term, and by 2a also. If we cancel, we'll get b the whole square. Are you understanding me? Say for example, I'm taking a number that is x square plus 4x plus, can you tell me what will be that particular b term, or what will be the b square, or just fill in the blank. So what you will do, you'll take 2ab term and divide it by 2a term. Okay, this is x. You need to divide by 2. Why? Because we have 2ab term, so we need to remove that 2 also. That is why we are dividing. This cancel, this is cancelled 2, so you'll tell me 2 square will be here. So that is what we are doing here. We are taking the x coefficient, which is a 2ab term, divided by 2, and that number we need to just square it, and that particular number we have to add and subtract to balance it. That is why we need to subtract and add. So we are doing such type of thing here. So what you need to remember, coefficient of x, divide by 2, square it, and that square you have to add and subtract. Now take this term and this term, close. Okay, and plus of 8 and 2 square is what? 4. So we can write here. Now this is nothing but x minus 2 the whole square, isn't it? A square plus b square minus of 2ab term. Are you getting it? So that is why the name suggests, no, completing the square. We have actually completed one square. Plus 8 minus 4 is what? 4, which can be written as 2 square. Can we? Okay. Now, isn't this very easy for us to solve? Because we know the integration of x square plus a square, which is 1 upon a tan inverse x upon a plus c. So in place of a we have 2, so 1 upon 2 tan inverse. In place of x we have x minus 2 upon a, that is 2 plus c. That's it. Alright, so the main understanding in this question you should have is of these things. Because you know, in each and every, that this is only the first form I have explained you. In the second form, third form, fourth form, all the forms you have to remember this completing the square method. We'll see again and again. We'll see this completing the square method in each and every question. You'll be master in doing that. Okay, so don't worry about it. Okay, let us come to the second form, which is integration of x plus 3 upon x square minus 2x minus 5 dx. Which is of form what? Integration of px plus q upon ax square plus bx plus c dx. Okay, so let us do this form. Let us see this form. So you have to remember the criteria for this form also. What is the criteria? So it says numerator equal to a into a and b are some coefficient, a into d dx of numerator plus b. This is the very important thing which you have to remember for particularly this form, or maybe we'll see in the other form also such type of thing. Okay, so numerator, what is your numerator? X plus 3 equal to a into d dx of denominator plus b. Okay, now differentiate this. What will be the differentiation of x square minus 2x minus 5? So it will be 2x minus 2 plus b. Now multiply a inside. So 2ax minus of 2a and plus of b. X plus 3 which is going on. On comparing the coefficient, let us compare the coefficient of x and x here. So it will be 2a equal to 1, and here 2a minus b equal to constant with constant, variable with variable. So we got a, the value of a as 1 upon 2, and on substituting the things we got value of b is equal to 4. Now just remember, as you differentiate your equation, no, just make it star. Give this equation as the star equation, because we have to put the value of a and b in this equation only and not in this equation, because this is we have to differentiate, right? So don't put the value of a and b here. As you differentiate the very next step, no, you have to put the values of a and b. Okay, so I'm going to rub this one because as there is some there is no space, so that is what. So x plus 3 equal to, put the value of a 1 upon 2 to x minus 2 plus what is the value of b, 4. Now I am rubbing this calculation. This is the part of solution. Please mention this in your solution. Okay. So we got the value of a is half and b as 4. Don't solve it. You will get x plus 3 only. Okay. This is what we are representing x plus 3 as this whole. So in place of this x plus 3, we are going to put this whole expression. So let us put. And you know, I'm separating also. So two work I'm doing. Okay. Substituted the value of x plus 3 as this one and separating also. So this is nothing but 1 upon 2 integration of 2x minus 2 upon x square minus 2x minus. Now you know how to integrate these things. Here you only need to take this is equal to t. So you consider, let us solve the first this thing, then we'll integrate this thing and we'll combine it. So first, let us first take this thing. So we are taking, let us first separately integrate it. So I told you, you consider the denominator equal to t, differentiate it. You will get 2x minus 2 dx is equal to dt, which you already have in the numerator. So you know, in each and every question for solving this particular form, you will get such type of two situation where this situation very easy to solve. Consider the denominator equal to t, differentiate it, you will automatically get the numerator. That is what we did here. No, just to make the differential coefficient of denominator the same, that is what we considered a and b, and we found that particular coefficient so that we can make this x plus 3 as the integral, as the differential of this denominator and one another factor. So that is what, consider this is equal to 2 t, that is 2x minus 2 dx is equal to dt. Then what we can do, we can, in place of this denominator, we can put t, so it will be dt upon t, and we know how to integrate this thing. The integration will be log t plus c. So 1 upon 2 log, in place of t you again put this. Hence the integration of this is this thing. And what will be the integration of this? Now you have to use the first form which we have seen. Alright. So here, using completing the square method, what is the coefficient of x? 2. Divided by 2, you are getting 1. Square of 1 is what? 1 only. So 1 you have to add and you have to subtract. So I directly did here. And as you can see that this is x square minus 2x. So just to complete its square, I need only plus of 1. So for that I need to do minus 1 also. So that is what we did. So this and this plus, you will get x minus 1 the whole square, minus 1 minus 6, you will get an minus of 6. So we can write minus of 6 under root minus of 6 the whole square, just to fit it into our identity. Which identity we will use here? Integration of 1 upon x square minus x square dx, which is what? 1 upon 2a log x minus a upon x plus a plus c. Okay, so this is how we have to solve. Okay, after that you know how to just solve it and combine both the integrals, you'll get the final answer of this particular form. Now as I see that this two form only took our whole time, so no problem, no worries, we'll go very slowly, no problem in that. So I want you to make it clear both the forms of form 1 upon a square plus bx plus c dx, and this form integration of px plus q upon ax square plus bx plus c dx. Just make it clear both the forms. In tomorrow video, we will come up with integration of 1 upon under root ax square plus bx plus c equal to 0. You know, this is very easy. The same thing you have to do in the under root, and all the under root identities we have to use. That is integration of 1 upon under root a square minus x square and x square minus a square. Okay, what is integration of 1 upon under root a square minus x square dx? That is sin inverse x upon a plus c. And integration of 1 upon x square minus a square is log of x plus under root x square minus a square plus c. So the form, they both are matching. The criteria of solving both the question, this one and for the under root, they both are same. So I don't think I need to explain you that particular form. So that form is also completed, as I am considering that that form is completed because I believe on you, you will do it. So you have to do it and you must do. Okay, so complete this form. And regarding that under root of a square plus x square, I'll teach you in the next video. Don't worry about it. Okay, so till now, I hope you will do. Just go through all the examples, not all, the starting one. Okay, and the exercise questions also, just try to solve it. If any problem, then just get in touch with me regarding the same. We'll make it clear in the next video. Okay, till that, do practice. Thank you so much. Have a nice day. Bye bye. Tata.